Hi, this is Mariusz Antonik. I'm gonna present you today the deep information about the load balancers. What is the load balancer? What is it used for? And how you can use it. Oracle Cloud provides two different load balancers. One, this is the network load balancer, and two, HTTP load balancer. Now, the network load balancer, allow you to forward the ports that each application is communicate with the server using some port. For example, the HTTP is port 80, HTTPS port 443. The database like MySQL database is using the default port 3306. You can of course configure your own custom ports, but those are the default port. Now the network load balancer allow you pass the traffic which coming on this port through the load balancer to the backend server. Okay, doesn't do anything here, doesn't validate your traffic, doesn't check your traffic, doesn't check what's coming through. It's just okay, coming on this port, I'm gonna forward you to this port. Of course, those ports can be different. Like for example, we can set up here, let's say 1080 port and redirect this to port 80 here, okay? Because the port 80 is the backend server, port 1080 is your incoming server. Right, that network load balancer allow you to communicate and forward port on the TCP and UDP level. Okay, now what is the TCP and what is UDP? I think in the simple terms, TCP is doing the handshake, that now if I'm talking to you, you're responding to me, I'm talking to you again, and we exchanging the handshake. Once we exchange the handshake, we are agree how we're gonna communicate, then we continue communication and exchange the future information. Now the UDP is just like I'm telling something, but I not listen. I don't know if you hear me or you didn't hear me. I think this is the easy and simple understanding what's the difference between the TCP and UDP. Okay, now the load balancer, in setting up the load balancer, you're setting up using the backend server and listener. Now you're setting the backend, and in backend you're setting up the two or more servers which you have configured, and listener is on which port it's gonna listen. Okay, that listener is listening and then forwarding to the backend servers. Okay, now the next is the HTTP load balancer. HTTP load balancer allow you to load balance the HTTP, HTTPS traffic as well as TCP. That this load balancer can be used to TCP port forwarding if you need, or you can use this to load balance your HTTP, HTTPS traffic. Now, when you're using the HTTP or HTTPS, your request is coming to load balancer, and load balancer is decoding this traffic, and now it's forwarding over HTTP to the backend servers. If this is HTTPS, that load balancer is closing your, it is providing you SSL, that in the load balancer you have to set up your SSL certificate. This way, when you're coming through the SSL, HTTPS connection, you're coming to load balancer, and now load balancer is decrypting, and now you have an option to forward back to backend server using HTTPS or using HTTP. If you're using HTTPS, the backend server has to be configured with SSL certificate. That means the app server which is behind has to provide HTTPS connection between the load balancer and Apache. If this is your decision based on the application which you're using and your requirement, if you need to have HTTPS communication between the load balancer and Apache. The load balancer is your endpoint from the public perspective. Okay, in load balancer have a limits. The limits in the configuration is the maximum 16 hosts. If you're using the free tier, then there's 10 hosts, and max backend is 16. If you're using the free one, it's 10. We can configure the SSL, we can configure the routing policy, roles, and host names. Okay, and now let's review a little bit each of those configurations. The roles. In load balancer, we can configure the access control. Now, what's the access control? Access control allow us to define who can come, what CDR can come to our server. That means if we creating the website which has to be accessible only from specific network, then you can use this access control list and narrow down only that specific public subnet would need to have access to your website. This is the single host who need to have access, your client office which has to have access to that website, that you're putting this into the access control list. The next is the access method rules. Access method rules are the way how we requesting the data. That means something like get, head, post, put. Those are the most typically used HTTP method. When you see this drop down, when you will be configured, there is much more options to select, and those will depending from your application. The typical for the website, it will be get, head, post, put. Actually, I don't think even put will be there. Most likely a get, post. Those methods will be the mostly used. But when you start doing the accessing and filtering access rules, you have to make sure your application is fully working. That after you add this, make sure you perform the correct test that you validate your website is fully working. Specify URL redirect rules. Now, in this section, you can define what to do if you're coming with a specific rules. That, for example, if you need to change something to something else, for example, you have one URL and your configuration is still coming to this URL. You have DNS, you have a post there which are coming to that URL, but whatever reason is you change that URL and you want to redirect to something else, you can use this here, this configuration that configure that if you're coming with this URL, redirect me to different server, different backend, or rewrite the header. Okay, that all those redirection it can happen, can be handled by load balancer. Specify request header and response header. Specify HTTP header rules. That this is the three sections which allow you to manipulating with the header, when you can add, remove the header. If your application has to have some special handling, or you want to pass some additional information between different servers or different network equipment which you are involved with, you can use this section to add that additional information to that. The next section is load balancer routing policy. Now, the routing policy allow you to create the groups of the backend servers to which you're gonna route the traffic based on the request. For example, let's imagine that you have the servers which handling the application, which could be two servers handling the application. For example, you have a Java application and you dedicate two servers for that. And then you have a static content, like images. Now that static content, it's handled by separate two servers. This way you have a set of the servers which is doing the application request, and then set of servers which have the static content. Now, you can or mix this all together, but let's say you want to separate this, right? that now, without adding additional URL, because everything is supported by the same URL, that you have a primary URL, you're coming with that URL, but different URI, right? Like for example, /images, /app, right? And now, if I'm coming with the /images, I want to go to the servers which support the static content. If I'm coming with the app, I want to go to the servers which support the application only, right? That I have two different legs. And now I can build two different backend sets, one backend for application, backend for static content. In both, set up the respective servers which are behind those backends. And now here, I can make the rule that if I'm coming with a /image, then redirect me to the server which handle the images. If I'm coming with the /app, redirect me to server which handle the app condition. Okay, that all this, it can be handled by the routing policy, and of course by depending on your requirement for building your application. The host name. The host name is defining your URL, your domain. Now, based on this, there is two steps. First step is you adding the hostname to the hostname list. You create the hostname, and usually I'm putting the name and hostname the same. This way I have a very clear picture and understanding. And now the second step is in the editing the listener, we have to define that hostname. Now, when the request is coming in, the request is handled by that listener. But now, if you have, let's say, 2, 3, or 4 different URLs, and each URL is going to the different backend because it has to be handled differently. And now you can create multiple listeners on, and for each listener add different host name, and then redirect that listener to the different backend. And like you see here below, there is the routing policy where you're defining the route, which we talked about this in this step before. Okay. When we configured the backend, okay, that we talk about the configuration, how we can prepare the configuration, and now we need to set up our backends. That when we're setting up the backend server for our load balancer, we have two options to define the health check. The one is just the TCP on that port. Okay, it will be? Okay, as long as that port is open, that I'm good, right? That let's say if I have a just load balancer and Apache, Nginx, or any other web server, as long as port 80 by the default, or 443 if you're using the HTTPS to internal connectivity, if that ports are open, that's okay. I'm good. I can send the traffic because now I know that server is active server. But if you want to little bit improve your health check, add the HTTP call and validate the response. Like for example here, I'm using the port 80, but also I defined the health check HTML file. And in that file, I put just the number 1. And now the load balancer is going to that server over the IP address. That's important how you're going. Load balancer always is going over the IP address. That when you're setting up, make sure that that request is valid request. That you're coming to the to server over the IP address and you're requesting the health check HTML. And now, okay, I have the file, I'm returning the file, and now it's that file contain the number 1 in the response body. Okay, if those conditions exist, then that backend is good. Okay, in this situation, this is very simple and easy, and you may say, okay, why I have to go like that? And yes, right now I can just, let's say the port, just the TCP on port 80, it's good enough. Or just the status code 200 for the index pages, it's good enough, right? But if you have more complicated application behind the scene, right, you want that health check. You want to make sure that that application, not just the port is open, but that application is returning you success, and you can drive the traffic to that application. Okay, what I'm talking about, for example, 3-level, the load balancer, Apache, and let's say some kind of Java application, Tomcat, right? The Apache, it's doing just the proxy, right? That you have a Tomcat 1, Tomcat 2, Tomcat 3 maybe. You have different applications behind the proxy server, right? And now you want to make sure that those application servers are active. That when you're creating that health check for each backend, make sure you're reaching that application, and that application responds you back. This way you're sure that when you're sending traffic to that backend server, this application is up and running. Okay, that when you're designing the backend servers and health check, ensure that backend, your application really, which you have to reach, it's really active on that server. Okay, join my Facebook group, Always Free Cloud, where we'll talk in more deep details about setting up the load balancers and exercise. That when you exercise this, it is not just you hear this, you know how to do, you exercise this, and when you exercise this, you are able to perform more advanced network build. See you there. Bye.